So guys, we have started with the Hadoop installation. So we learned about the big data scenario, and we have learned about the challenges that big data gives us, 4 V's and all that. And then we started with installation, right? Hadoop installation. Though we discussed about Hadoop being a distributed environment, because we cannot bring in the hardware, we are trying to install it on a single node, right? Single node installation. This is called as pseudo node. Pseudo installation or pseudo cluster installation. Here we have 5 services that has to run. All of them are running in the same single node. The 5 services: name node, data nodes, secondary name node, right? Resource manager and node manager. The 5 services, right, are running on a single node, right? Ideally, when we talk about a cluster, remember it will have multiple nodes. So one node will have name node. You might also configure resource manager in the same system, or you might also have an alternative. Then we'll have data nodes configured in these slave nodes. All these will have data nodes and node manager service. And you'll also have a secondary name node which is connected to name node. Right, this is how it is basically designed. Right, the name node is designed like this. And in order to start with these services, remember it is installed or it is designed or developed using Java. So we need Java development kit, right? We basically have JDK installed, JDK 8 installed, and then we downloaded open source Hadoop from Apache site, and they have installed it. Then to configure Hadoop, we have to update the configuration files. Now these configuration files are located in conf folder, which is etc Hadoop. So the software that you have installed, under that you have a folder called etc. After that you will have a folder called Hadoop. And the configuration files will generally be in XML format. Typically, they are in XML format, friends. And the primary files that we need to edit, which are there in this folder, are core-site.xml. Core-site.xml talks about the core configuration of your Hadoop, core configuration things about your Hadoop. Then we have hdfs -site.xml. This will hold all the HDFS related components. And then we have Jan-site.xml. These are the 3 files that we have to edit. And when we talk about editing the parameters, we generally edit the replication factor. By default, it is 3, but you can set it. Block size can be updated. Again, block size is by default 128 MB, but we can set it. The data node, name node locations. This is something that we define. I'm talking about the mandatory things basically here. And then, of course, resource manager, the port numbers that we talk about, right? For various services, the port numbers that we use. These are the things that we have to edit in this files. But if you want to learn more about these files, then we can go to apache.hadoop.org, or I should say hadoop.apache.org. Let me erase this. And here we'll talk to documentation. We'll come to 210.1. And then under the last step, right here on the left side, we have core-default.xml, hdfs default.xml, then Jan-default.xml. These are the three files that you might want to go through, which talk about default settings. Right? I'm giving you hints. Go through these files, understand what all parameters are relevant for each of the file. Right? Go through this. Now, in order to start the services, right? Once the installation is done, in order to start the services, we need to execute JPS command, which basically talks about Java background processes. Right? So I'll say JPS to check if my services are up and running or not. Let me maximize this. Maximize this. JPS, there are no Java processes running. Right? You can say man JPS. Monitoring tools, list of instrumented Java virtual machines on the target system. Right? Java processes come out. And now to start Java service, Hadoop services, we need to execute two commands. So Hadoop basically has three components, which are broadly divided into two sections. One is the storage section. The other one is the processing section. Storage is HDFS. Processing is MapReduce. But the MapReduce, if I have to manage it properly, then we need to have a cluster manager also. Right? And this is nothing but Jan. Jan will manage these services. Right? So these are the two components that I have to start. And to start the services, the scripts are located under Hadoop home, Hadoop_home / sbin folder, secure bin, right? Or you can say scripts bin. We'll go to terminal and we start typing this. Say STAR and double tab, twice you tab it. It will show you, Linux prompt shows you what all commands are there which start with start, this particular word. And here you can see all the start scripts. Start all file is also there, but we don't use it. Now, if you try to use it, I'll show you. You see, it says the script is deprecated. Instead, use start dfs.sh, start yarn.sh. So it's specifically asking us not to use it because they stopped using the script now. Okay, I'm doing Control C so that I can basically come out of that command. Right, don't use start all, use start dfs.sh. CMD command is for Windows. Now when we start, it starts name node, data node and secondary name node. When I say dfs.sh command, it will prompt the password, prompt for password, give the password and enter. Make sure you're typing the password correctly. For security reasons, it will not show you the password that you're typing. So data nodes, data node, name node, and now secondary name node. So this is how we start our name node, data node, and secondary name node services, which are supporting the storage component of your HDFS. Once the services are started, you should see this three names, right? These three services being started. Now to start yarn services, we say start -yarn.sh. Now I always, okay, let me just give the password here first. Make sure we are giving the right password. Okay, let me finish this. Yeah. So it is asking for the password on resource manager and node manager. It started off. And if you look at this, JPS, didn't start resource manager. Strange. I think my password that I've given is wrong. Yeah, now it started. So I have all the 5 services up and running. Now remember, I was just trying to give you some hint a few minutes back. Yeah, the hint is always try and remember to use tab button. Right? In Linux, anything that you type, if you use tab, it will prompt you all the words which are starting with that tab, with that letter. Right? If I say ls, see there are so many words, right? If I type p and press tab, it will not work. Okay, cd dot space p, right? If I type tab, it is not working because there are 2 folders which start with P, capital P. If I do double tab, it will show those values. Now in this, I have pictures and public, PI, PU. Letter changes, right? So I will say PI and now press tab. So there is no other word which is starting with PI, right? Single word is there. So it is auto filling. Try and use this feature so that you don't go or you don't do typo errors. Use autofill option. Right? Try and use this. All right, now we have started Hadoop services. Okay, so imagine we have a Hadoop layer. This is a cluster. Right? Imagine that we have multiple nodes. Like this, we'll have multiple nodes interconnected. Each of this computer, right, is interconnected to other, right? Like this. And each of that node has a disk space, storage space, right? Disk. Virtually, we are trying to read that entire storage space of all these devices here. This is HDFS. We are trying to map, right, all these disk storage spaces at single location. So the end user would see this, not these disks, right? Now on this disk, you want to work. Basically, you want to do some kind of data storage or data manipulations. So how do we do that? Remember, this is HDFS. This is Hadoop file system. For the user, this is the system, right? This is Hadoop. For the end user, this is Hadoop, right? So this is the disk storage space for Hadoop computer. This is one computer, right? So for this computer, we have storage space, which is HDFS. So the file system is HDFS, but that HDFS file system is based on the underlying servers or nodes, which have respective operating systems, Linux operating systems, and they have XFS file system. Remember? So if the end user has to work on this file system, which is physically does not exist, it is virtual file system, underlying commands that we are going to get, these underlying commands, the commands that we are processing or executing, they have to get executed on these physical systems ultimately, right? Which has XFS file system, Linux. So the commands that we do on Hadoop are very similar to what we have learned on for Linux commands, right? In the last session, I was giving you that hint. So to start with, we will say Hadoop version, right? If I say Linux commands only, guys, we will be typing on Linux terminal only. We'll say Hadoop version, and it is giving us the version information, right? Now remember, this is Linux commands, okay? Physically, there is no HDFS file system. It is a virtual file system that we have to see, right? Now, ultimately, it is lying on top of XFS, right? So the characteristics of XFS will hold good for HDFS. Now in XFS, the Linux file system, everything starts from root, right? And then you'll have a bunch of subdirectories. Same way here also we'll have root and then subdirectories, right? Now I want to see the file system content. So generally we say ls to see the content, right? ls is the command. Now if I want to see the content which are there on Linux file system, right? Then we'll type this Hadoop fs. So my instruction is going to Hadoop file system. Yeah. We are basically going to Hadoop file system. And what command you want to type? I want to type ls only. But this ls has to happen on Hadoop. So you say ls and then give the destination, because in Hadoop, it basically is starting at root, right? Just like Linux. This is the command that we have to type in to get the information from our Hadoop file system. But there is no response, right? There is no result. Why there is no result? Because when we created Hadoop file system, remember we formatted and then started, right? The entire file system, we formatted. So that means there is nothing under root. It is an empty file system. Yeah, so there is nothing there. So we will go, we will basically do Mkdir, right? We will try to load some data. Okay, so I'll say Mkdir. Mkdir is nothing but make directory, right? If I say Mkdir test here, I'm getting the test folder, right? I'm going to remove that because I don't want to create the test directory here, but I want to create the test directory on Linux file system. So whenever I have to, Hadoop file system, whenever I have to do that, I have to use this keyword. I'm saying the instruction has to happen on Hadoop, right? Hadoop file system. What is that instruction? I want to say make directory, right? What directory you want to create? Test. But where is that location? Under root, right? Mkdir/test. Done. So we have created a folder called Mkdir under root on your file system, Hadoop file system, not in the local. How do I learn that? How do I see that? Again, I go with Hadoop fs-ls/. ls is list the content. Look at that. Now I have a folder. Yeah. So this is how we basically create folders, right? There are a bunch of other commands that we might want to learn. Now, generally, here, if I say ls-r and then dot, what is it doing? Okay, let me cancel this. I'll do ls first, and then let's say I want to see what are there in, let's say, one folder, okay, documents folder. So I'll say ls-r documents. Rather than all the files and folders, I'll just say documents. There's nothing, okay, strange. One second, let me see here. There's nothing, huh? Okay, fine. So what I will do is, I'll say ls-r of big data and then Hadoop file system. When I do this execution with -r option, right? When I did just big data, it is going to show me the SOP contents, right? The contents of this folder. ls means content of this folder. When I use -r, it basically means recursively show me the content which is there under this folder. So under this folder, I have data node, name node. Under data node, I don't have anything, but under name node, I have all these folders, this file and this folder. Under the current, I have all these files. So recursively, it has to show entire content, directories, subdirectories, files within those subdirectories, right? Everything will be revealed when I say -r. That is the same command that I'm typing here. So space this, right? Recursively, we capture the data. Then report the amount of space used and available on currently mounted file system. So right now my file system is Hdfs file system, right? Hdfs, that's the file system. So we say Hadoop fs count. Hadoop fs -count Hdfs : / That is the command which basically gives us the count of files and folders. So only 2 folders, number of directories. Right, there are only 2 folders. Then I also have file system check, Fsck. This Fsck is a utility which checks the file system for you. Hadoop Fsck, and what is the directory? This one. But when I execute this, it will again show me an error saying that Hadoop is deprecated to be used. So it says use of the script is to execute is deprecated. Instead, use Hdfs command for it. Right? But it still executes, but it says it is deprecated. It's not going to be developed any further. What is the stage? What is the current state of that particular command will remain same. It doesn't get enhanced. Right? So this is basically talking about the file system. You can also do the same command, but this time you can say Hdfs Fsck Now it doesn't throw any error message, but it gives you the same report. Right? So this is your name node. This is your Hadoop. Let's try and see. Let us try this. Oops. Firefox takes a lot of resources. Let it get loaded. Yeah. So here we are going to paste that. Yeah, you can see here it says Fsck. Execute till here. If I say host name colon port name, this is what you're going to get. This is for your Hadoop GUI, guys. You can explore this. Whatever is your host name colon 50070. So syntax is, you can directly, I mean, if you're typing it in the local system, then you will have to basically say host name colon 50070. You can say http colon / and then this. Okay, try that. You will get the details, and you can also learn about data nodes. This is your data nodes. Disk usage of data nodes is shown, right? And yeah, you can also click on this to go to your data node location. This is your direct data node location, 7.5. Then we can also use startup process, data node volume features. There's nothing here basically. Snapshot is like a backup summary. And then startup process. This is how it is getting booted. Utilities, you can basically browse through the file system and all that. This is basically your directory. So we basically created one folder, right? Test. So it shows the right files and folders in this particular utilities location. So this is like a graphical user interface. Yeah. You can also upload files from this front end option. And you have cut and paste. Right? Then yeah, you can also see your permissions here. Permissions are also given. Yeah. Now, let us proceed with the next commands. There are very important commands that we need to learn. Okay, Hdfs Balancer is basically trying to balance the load on data nodes, right? We can type this and see the result here. And say Hadoop Balancer. Again, this is also saying Hadoop command is deprecated, use Hdfs instead. The cluster is balanced. No task at all, right? So it's okay, and you don't have multiple nodes here. Name nodes is this, right? And using that name node, we are balancing the load on the data nodes, right? Get blocks and all that is it's doing basically checking the balance on the data nodes. You might want to go through each line what it is doing and all that. Probably you might not understand much, but it is basically trying to, if you have multiple nodes, then it basically does that. Okay. And then we have Mkdir, we've already seen. Okay. This is important command, put. What does this put command do? Okay. There is very similar command to put, which is copy from local. Put or copy from local, both are similar. What does this actually do, and what is the difference between these two commands? So minimize this. See, we are working with a cluster, right? So this is the HDFS, which is physically not existing. It is a virtual storage, right? For a client, this is what he's going to see, but physically, these are the disk storage space, right? Now, there is a file I want to store it here. There's a file that I want to store here. So what we're basically saying is from local, I want to put a file into this. So put command is basically to load a file from local to HDFS, right? So we are imagining that we are here physically. This is where you will be, right? So you will be here physically, and you're saying from here you put a file into this, right? So that's the put command. Now the same task is done using a older function, which is copy from local. We have copy from local, right? What is this copy from local doing? We are imagining that we are here in the virtual layer. Okay, this is an old command. Okay, this is an older version. And at that stage, we were imagining that we are in virtual location. And then we are saying, hey, copy a file which is there in the local and bring it here, right? Copy from local to this. So both are doing the same task, but you're saying, hey, there is a file, copy from your local file system. Okay. Now, if I have to take a file from HDFS, what should be my command, guys? You understood put and copy from local, right? What should be my command for doing the reverse action? That means from HDFS, I want to get a file to the local system. What would be my file? What would be my command? Yeah. Yeah, simple. That's right, Saurabh. Get command. Right? So I'm imagining that we are in this level, this level, local level. And what we need, we want a file which is there here on HDFS. So I'll simply say, get that file here, right? I would simply ask to get that file from here, there, HDFS to local. So get. So this is hyphen get, right? Put and get. Now the older version, what do you think? You are in the virtual layer. At this layer, you are here, but I basically have to do a copy of file from HDFS to local. So what do you think? What kind of command would be there here? You're saying copy from local. So this is copy to local. These are the two very, very important commands that you'll have to remember, guys. Nowadays, nobody's using these older versions. Put and get is what we use. It's more short and very easy, convenient to type. And also, logically, you can only be present on a physical location. You cannot be on a virtual location, right? So that's the logic. So put and get is what we use. So let us look into a local file. I have a local file called Hadoop cluster setup. Dot means current location. Even if you don't give, by default it takes dot. So it is 4682. That's the number of bytes that I have. Size of the file. Now I want to copy this file to HDFS layer. Right? So what should I use? What command should I use? What command should I use? Put command. Very good. Yes. Now, whenever we write Linux command, there's the syntax for Linux commands, guys. Remember this. Linux OS commands syntax. It always says the command space source space destination. Command space source space destination. Right? So this is basically the syntax, standard syntax. Wherever it is, of course, applicable. In some cases, we'll have only destinations. In some cases, we'll have only source. In such case, you'll have command and that particular value. So you might say ls, there is only command, there is no destination or source for that matter, right? By default, you'll have dot. Dot means current location. Yeah, so that's ls for us, and here we are typing ls -l. That means that's the command, and the source is dot. Dot means current folder. Same way, I want to put this file onto HDFS, right? So I would say Hadoop fs -put. This is the command. -put is the command. What is the source that I want to copy? This is the file. Source file is given Hadoop _ cluster _ setup.txt. Okay, that's the file. I want to put this into a destination. What is the destination? When you say put, by default, Hadoop fs -put, imagine that the destination is Hadoop location, HDFS location, and in HDFS I have /test folder. Under root I have a folder called test. So I'm using this. Now what happens is the file is getting stored in that location. If you want to see Hadoop fs -ls/test. Within that folder, you might want to check what files we have. You have that file? You might also want to check from the graphical user interface here. We'll just do revision, refresh, and you see here. Now, what is the replication factor that we have? Replication factor is 1. By default, we have set it that, right? Now, let's say I want to upload another file. Let's browse it. I'll go to home. Probably I'll go to, let's say, big data. Then I'll take some random file, okay? Let's say jmc.txt. I want to copy this into HDFS. So this is my local file system. Open and then upload. Why is it not able to upload? Strange. Couldn't upload the file jmc.txt. Let us try from the backend. It was there in JDK. JMC text. Okay, let us try and do this. Hadoop fs hyphen put jmc dot text to slash test. There will be a lot of restrictions in GUI, so it's better always use this. Now it got it. Right? So why is it not able to load us? Something that we have to see. Okay, 3.2. Okay, I'll take this bytes, smaller file. There's some issue in here. Probably some kind of a not sure, but some kind of a command might be, something might be hampering the copy, not sure. It should be able to upload here also from here. You might want to create directory, you can just create a folder. Inside test you will be creating, because we are here inside test, right? Hence it's giving that information. Right, I can also go out. So this is my slash folder. Right, this way we can basically manage your Hadoop file. Copy. Now, if I want to copy a file from one location to another location, we generally use cp command, right? cp is basically done at the same layer. So if I have local file system only, then cp basically works to copy a file from one location to another location. Now, the same way cp command can be applied, right, onto the Hadoop files in Hadoop layer. I don't have to use put command. Put comes into picture when we have the file copying from local to Hadoop, right? So cp command can be tried. I can show you that. Let me just try and do this. cp command as a Hadoop fs -ls -r/. So it looks into the directories and subdirectories. So you can see that I have system and I have by default system folder will be created, and then I have test folder. And within test, we have two files that we have loaded just now. And that one that you are seeing, here you see one, right? This one is basically the replication factor, right? We also have a replication factor. Now I want to copy, let's say, JMC file to a different name outside the test folder. So I'll do Hadoop fs-cp /test/jmc.txt/ let's say x.txt. I'm copying JMC into x on root. So again, I'll say -ls -r/ you can see x.txt will also be created. So test, under test you have these two, and under slash you have x also. You want to see the content, then you are going to say Hadoop ls -cat /x.txt. Error, could not find or load. This class ls. So what is the content here? The same content. You might want to cross check on the local. This is your local file system. Here, what is jmc.txt? Oh, there is a lot of content. Why is it not able to load? this is the issue. It has to load. Okay. This is clearly given. Block 0, block ID, block information is given. Head of the file, 32 KB. Yeah, it's showing. It is showing it here. Then why is it not showing on the Hadoop fs-cat/x.txt? It's not able to read the content. It's a flat file. It has to show me the content. Now it is showing. Yes. Yeah. So this is how we basically have a file system where we dump our data. Right? Now, you can also use DU, disk usage. Right? If I say Hadoop fs-du, right, disks usage -s/test. H means human readable format. It basically gives you that, right? Okay. I can also say -s. Yeah, it gives us the content like that. Total sum basically. -s means sum. Right? So this way you can also read the disk storage space. Now I want to remove. Then rm command is used. We have already seen that rm command, right? So rm will remove the file. So let me say Hadoop fs-rm/x.txt. Easy. So let me remove this. Deleted. Now you can also look into the front end option. You can see x.txt is gone. It's not there. We deleted that. Right? Here I have these two folders, these two files. We can also remove JMC if you want to try and check that. I'll say /test/jmc.txt. Deleted. You see, I refreshed and that file is gone. Right? So this way we can basically remove the content of or manipulate your content in HDFS. Right? You can also try and do expunges to remove the empty or free up the recycle bin. In Windows, we generally first delete the files, then it goes into recycle bin, and then we go to recycle bin and flush it, right? So here, that recycle bin is nothing but trash. Expunge is going to clean the trash also. And if I want to remove a folder, then we say -r as an argument for rm command. Put or -copy from local. We have seen -cat. Cat is a command which is used to read. Right? Then CP also is something that we have seen. Copy the content at the same level. Right? If I have to copy the content at the same level, then we do that. Then we have get command, which is to get the content. We have on Hadoop. Then again, I'll say Hadoop Fs -ls -r slash, and there is only one file that we have right now, which is your Hadoop cluster setup. The other things are deleted, right? Now, what I will do is I will use get command. Now, for get, what is the source and what is the destination? Now, you cannot do that CD, Ashnar. You're not in that physical location, right? You cannot do that. Slash is root directory. If I say pwd, where is this path starting from? Slash, right? That is called as root directory. I've explained about Linux file system, right? So that slash is root directory. I'm saying under the root, what do we have? ls slash. What will I get if I do ls slash? It will show me the content under the root directory. One of the directories home, right? One of the directories home. That is exactly what I'm doing on Hadoop also. Yeah, so Ashnar CD cannot be done. And yes, Hdfs will be the source and destination will be our local. So again, I'll say Hadoop Fs source is /test/ the file name. Unfortunately, you have to type the complete name. You cannot use the tab button in Linux. So I will choose this. Remember, we want to use get command. So I will say hyphen get space the source. And where is the destination? Where do you want to store it? I want to store it in /user1 home/user2. And in the test folder, I don't have test folder here. Let's say I want to create it as Hadoop _setup.txt. Or I'll say Hadoop.txt in short. Let's say Hadoop.txt. So there will be a new file created in the local file system with the name hdp.txt. Look at that. If you don't give a name, then the same name file will be loaded automatically. Okay. So I'll do cd enter and we are in the list location, right? home/user2. That's the path I'm giving. And then I'm giving the file name as hdp.txt. You can see cat of hdp.txt. This is the command. And you can also do cat of Hadoop and do that. You'll get the same thing. In Linux, there is a comparison script or comparison command. You might want to explore that and do the comparison. So this is basically how get and put work. Hyphen tail will display last kilobyte of the file, 1 KB of the file. Right? Head is showing you the first kilobyte of the data. Then chmod command was used for altering the user permissions, right? Modifying the user permissions, change mod, right? So here we use the change mod command, right? Just like how we used it in Linux, right? Now I want to show you one more thing. Let me just explain one more thing here. Hadoop Fs -ls -r/. Yeah, so this is my file. And if you see here, this is hyphen, but this is 1. What is that 1? It is the replication factor. And replication factor will be there only for files, not for folders. Okay, remember that it will not be there for folders. Now we can also play around with the replication of the files. Okay, I'll come back to change ownership because I've started that. Yeah, this is the command. Set replication. Write two. That means you want to create two files, or you want to replicate that file to two copies, right? So let's use this Hadoop Fs hyphen Hadoop Fs hyphen. Let me first copy it into a smaller file. I'll say x.txt. I'm taking x.txt. Yeah, I have this file. Now I'm going to replicate it. Hadoop Fs set replication factor, REP, set REP. Want to write twice. And what is that file? x.txt. So you say Hadoop Fs hyphen set replication, and you want to write it twice, and you are giving the file name, right? So let us do this. Now, okay, my bad. I have to give a local file system, local file. Let me give any file. I have HTTP, right? HTTP.txt. So I'm basically copying this HTTP.txt file from my local location into Hadoop. Should throw error. HTTP, is it x.txt? I just forgot. Let me just try. What is this command? We generally don't do with replication. Yeah, so I'm basically pointing to that x.txt file, and it is replicating it twice. Now it says waiting for x.txt to get altered. Okay, we are trying to replicate it. Yeah. Okay, now it will just change the replication to 2, but in the backend, if you see, it's still waiting. Why? Because I don't have those nodes to copy that replicated file. I'm trying to replicate, the replication factor is set to 2, but in order to actually copy that into a different, replicate it to a different node, I need the node in the first place, but I don't have that node, right? Hence, it's just waiting for X. It just waits like that. So I'm canceling it. Control C is kill. Okay, I'm killing it, but replication factor is set to 2 only. Right? Now let that be as is, right? And I will also show you now something which is very, very important for our admins, HDFS admins. So HDFS DFS admin hyphen report is going to give you the report on all your file system nodes. So it's going to take all the nodes and then give the report. HDFS DFS admin.report. One data node is there. Right? Here you have the report about your data. Under replicated blocks. One block under replicated. Right? So it's basically doing this. You can also go back to that initial report that you did. Right? Here at the start we did DFS file system check, right? Fsck. If you remember, we did Fsck. Yeah, this one. This is file system check utility. We'll run this also. Hdfs Fsck slash. Yeah. Yeah, this is about your Fsck. Why I'm showing this is replicas is 2, but found 1 live replica. Right? So we have tried to replicate a file, minimum replicated blocks 2. Under replicated 1. Under replicated, right? We have one file, it has to be replicated once more, but it is not replicated. Hence it is under replicated. Default replication factor is 1 only, right? And missing replica. So you can see that there is one file which is missing. One replica is missing. So that's because here you have replication factor 2, but I have not replicated. I was not able to replicate it to any other location. You can delete directly from here also, right? Or we'll try to change the replication factor back to 1. Let us try and do that. Here I'll say 1. Done. So you should actually get this confirmation. It should say done. And you can see that replication is 1. Right. So we will take a short break now. Yeah. And we'll come back and summarize this, and we'll move on to talk about another tool called Apache Pig. Okay. We'll not spend much time, but we'll have to understand why Apache Pig is used for, what is it used for. Then Apache Hive is another tool that we'll try and understand why it is used, in what way, right? History. So we'll start with Apache Pig. And we use these for data processing, right? Let's take a short break and come back. It's 9:38 in my watch. You can see here it says 9:38. We'll connect back in, let's say, 7 minutes. Okay, break, guys. Hope everyone is back. Let me take the questions now. Which file is replicated? How do we know? All files. Yes, by default, whatever the replication factor you put, all the files will follow that replication factor. What we're doing here is hyphen set replication is basically setting a default other replication value from the default. If you want to over replicate or under replicate any file from the default value, then we use this command, okay, to override the default. Nabil, it will be there in recommended videos. It will be there in the recommended videos. Please go through the recommended videos. It is given for everyone by default. Please check there. When I type in Hadoop fs mkdir use training Hadoop, I get no. You should have that folder, right? Do you have that folder in the first place in Hadoop? When you do Hadoop fs -ls -r or just slash, if you do you see this folder? right? First create that folder, then it would be able to create Hadoop, then it would be then it would be able to create training under Hadoop, and then it would be able to create Hadoop. Directly, it will not be able to create this subdirectory. That's not possible. You have to first get this, and then this. Okay. Single command will not create subdirectories. That's not possible. Right. Now let us look into the command that we have to look at. Is all these are something that you can try and do. Okay. Safe mode is a command that we will try to do. What is a safe mode? We discussed this, right? Remember what is a safe mode? Yeah. What is safe mode, friends? Who remembers? Yeah, guys, safe mode. Replicating, no, replicating is different. Safe mode is different. Safe mode, safe mode, safe mode. Think. We generally see Windows starting in safe mode. When you basically run Windows, sometimes when there is improper shutdown, you will see this message which says Windows is not shut down gracefully. It is starting in safe mode. How many of you have seen that message? Read only, very good. Yeah, Rajni, I've seen that. So what is happening is when Hadoop is starting, right? At the beginning of its startup, right? The services when it is starting, Hadoop is looking into the metadata. What are the metadata files in Hadoop? Yeah, what are the metadata files in Hadoop, guys? Fs image, okay, and edit logs. Very good. Fs image and edit logs. Right, these are the two files. So what it is doing, right, in cluster, your name node waits for the information from data nodes, right? And data nodes send this information at every 10th heartbeat, right? Data nodes share the current status block information, right? Block report basically about the data node, individual data node to name node via 10th heartbeat, right? This information has to be verified from your Fs image file. Because when Hadoop is starting, it has to see for consistency whether the entire cluster is consistent with the data or not. So it will make a comparison of the current status of your data nodes with respect to the Fs image information that it has saved when Hadoop services were shutting down, when they were shut down, when the services were being shut down, the current status will be recorded into Fs image. So when you're starting, it has to be verified. Until unless the verification is done, Hadoop will not allow any changes to Hadoop, to that particular instance, right? So it will start in read only. That is called as safe mode. This is nothing but read only mode. And once it verifies the status, right? If there is consistency, then automatically it comes out of the safe mode. But if it is taking too much of time, or if you are in a hurry and all that, sometimes it hangs, okay? Sometimes it stays in safe mode only. So in such case, you can execute this, right? To leave safe mode, right? The name node that you are seeing, if you type any command, it will say it is name node is in or Hadoop is in safe mode. So use this command to come out of safe mode. But safe mode is basically by default, right? Status or by default stage when it is starting. Few minutes, it will be in safe mode. Next, if I say Hadoop Fs, just say Hadoop Fs here. I'll remove this, I'll say Hadoop Fs. This will list out all the commands that we can perform using Hadoop. These are all the commands which are allowed on Hadoop file system. Generic option. What generic option? These are all the generic options that we can do. You can append to an existing file. You can do cat, checksum, change group, chmod, change ownership, copy from local, copy to local, then cp, count, delete, create, dfdu. All these are the various commands that we can do on Hadoop file system. Right? You can also say help. Right? We can also say help. When you do help, it's like your detailed description about each command. It gives you detailed right explanation about all the options that we have there. This is like your manual pages. See, for copy file, what are the arguments? For copy to, what are the arguments, right? So for each command, it gives you a detailed option. Hyphen help. Right? So these are basically the Hadoop commands that we have in HDFS. Do walk through them, practice them. It also helps you to practice Linux commands, or you practice Linux commands and it will help you understand HDFS related commands. Remember, physically we are present on Linux file system, but we are operating on HDFS, which is a virtual file system for Hadoop, for your cluster. Okay, remember that. So this is about HDFS, guys. And now, when we talk about HDFS, we know that data is sitting here, right? Now, when we talk about processing, of your data, where is this? Let me go to this folder. So you're talking about Apache Pay, but why we have to talk about it? Okay. So when we talk about Hadoop, remember Hadoop comes up with two components. Storage component, that is something that we discussed till now, HDFS, and then processing or computing framework, which is basically nothing but your MapReduce. Right? And to manage these MapReduce services, we have Jan. right? Yeah, Jan basically is the latest version that we talk about, which manages these resource manager and node manager, which help us to map reduce tasks. Now, whenever we try to write map reduce code, processing code, it always has to be happen in a low level programming language, low level programming abstraction. So that's how your Hadoop is designed, right? Java. We can use Java, we can use Pascal, we can use C, we can use now Python also to write codes, but it is low level. And your map reduce tasks are basically split into map jobs and reduce jobs. So you'll have to write your code also in these ways. And it is low level language, so each step you have to explain to your computer on how it has to do, right? At a very low level. That means you have to be a specialist, a programmer, right? When before 2004, 2005, before Hadoop happened, organizations struggled with big data. But Hadoop happened in 2004, 2005. This basically helped organizations to deal with big data, and they were very happy because there is a solution now. But there is a challenge with the solution, which is you need specialists, right? Because Hadoop basically is developed using Java, so you need specialists. When I say specialist, you need programmers, right? Now, when we talk about data, understanding data can be better by subject matter experts or functional guys or business guys, right? Those people can understand data better, and what you need to do on the data, they can explain. But they cannot do it because they are not programmers. So to work with data, you need two different people, right? You don't get this kind of a skill set in single person, single resource. So organizations had a tough time. And understanding that code is also very difficult because it is low level. And the coding will also be very, very difficult because you have to define everything in a low level. Right? So a lot of organizations were finding it difficult to manage Hadoop service coding. Hadoop is very good in solving big data problems, but difficulty in managing Hadoop was there because of your map reduce capability. Right? Later on in Hadoop 2.x, Jan was released. Jan basically is a cluster manager which allows the map reduce task to be managed better. Right? Before Jan, it was job tracker and task tracker, which were managing everything. Job tracker used to manage everything. Assign tasks, then schedule it, then make sure that there is no failure in the transaction, right? Everything was managed by your task manager, right? But later on, Jan came into picture, which basically had changed the job tracker task to two different subtasks. We call it as resource manager. That resource manager basically splits the workload into application manager and scheduler. Okay, so two different subtasks where they were dedicated doing the separate tasks for your Hadoop. That's Jan basically. Now, thanks to this feature, a lot of high-level programming abstractions were developed. When I say high-level programming abstractions, people used to write code in some of very high-level, let's say, abstraction, like business language. They were not worried about jobs getting executed in MapReduce framework. They were creating at a high-level code. Now, this code would be internally transformed into map and reduce jobs. And the communication, thanks to Jan, right? It makes sure that these jobs get executed on your Hadoop. Right? So code gets converted, high-level code gets converted into map and reduce it automatically thanks to these high-level programming abstractions. And one such programming abstraction is Apache Pig. Now, Pig was basically used for ETL jobs. What does ETL means? What does ETL basically mean, guys? Yes. Extract, transform, load. Right? Data manipulation, basically. In short, we can say data manipulation. So extract, transform, load. Now, when we talk about big data, right, organizations were finding it difficult to do ETL. Right? Yahoo had that problem. So they decided to create a software which helps their employees to manage that ETL task on Hadoop. Remember, Hadoop is a framework. It's like a computer, right? And Yahoo basically wanted to collect data from different sources that is getting generated. Yahoo Messenger, Yahoo Mail, Yahoo Search Engine, Yahoo other applications. There are different applications for Yahoo. And a user with an ID might be using different of these applications, right? So the data had to be extracted from these different applications, right? Yeah, Informatica is exactly one of the softwares which is popular for doing ETL. Similarly, on Hadoop, we want to do it. Okay, we are trying to do it on Hadoop, right? So extract the data from different tools or different sources, then transform it, and then load it. You load it on Hadoop, right? So in order to do this job, Yahoo invented or developed a software. They called it as Pig because of the pig philosophy. Pig is an animal which can live anywhere, right? Eat anything basically, right? So on the same lines, Yahoo wanted to project that the software that they developed can work on local file system or on Hadoop file system. It can consume structured data, semi-structured data, or unstructured data, right? So to basically show these capabilities, they considered Pig as a name to their software, nothing else. That's the only reason, right? And it became an interface to data analysts who wanted to manage the data, right? ETL tool on top of Hadoop, that is your Apache Pig. Though Yahoo developed it, it was later on given to community. They did not own it. They give it away to community for further development. Right? This is about Apache Pig. And Apache Pig is more used by people who are not programmers. It's like a procedural language, or we call it as procedural language. It is more like an English communication, textual language, and we call it as Pig Latin. And the Pig scripts that we write, right? It's called as Pig Latin scripts. The benefit here is, remember we talked about Pig can work with structured data, it can work with semi-structured data, and it can also work with unstructured data. Whenever we talk about structure, schema will be there. For semi-structure, we can create schema. We can assign schema. But here we'll not have any schema in unstructured. But Pig software can deal with any of these, right? That means schema is optional for Apache Pig, right? And it can be customized. This is one of the features. Now, Apache Pig is more like a textual command where your subject matter experts can actually now use Apache Pig to basically write the functions that they want to accomplish. Right? And whatever they write, the scripts that they are writing, at a high level they write it, which is basically the procedural language. And these scripts get converted into map and reduce applications by your Pig engine automatically. Right? And the commands that you are writing, they get executed on map reduce framework. So the data is residing on HDFS. Right? We say data is residing on HDFS. We can also use data which is on local as well. Data can be on local as well, or your HDFS. By default, Apache Pig assumes that data is under HDFS. Right? It is, remember, a tool which is using Hadoop capabilities. So HDFS is something which is by default considered for Apache Pig. And it supports RDBMS kind of commands, SQL kind of commands. Okay, so it is also compared to SQL. Now, whenever we talk about Pig engine, this Pig engine is going to look into the scripts which are written in Pig language. Those scripts will be converted into map jobs and reduce jobs for execution purpose. Right? So in order to get this, Pig engine has different components. Right? Grunt shell, parser, optimizer, compiler, and executor. Okay, grunt shell is the command line interface where you write these scripts. You're writing scripts, right? Sorry. You're writing scripts, right? We call them as Pig Latin scripts. These scripts will be written in an interactive medium. For Apache Pig, this interactive medium is called as grunt shell. It's nothing but command line interface. For Linux, we have terminal, right? Command line. Similarly, for Apache Pig, you will get a shell, interactive shell, which is called as grunt shell. The terminologies will be related to Pig only. Pig's grunt. That's how they communicate, right? So we have grunt shell. Then parser. What does parser do? The scripts that you are writing in grunt shell, parser would check for syntax error, syntactual errors. If you are writing the code logically correct and if there is no syntax errors, then parser would pass that command. It doesn't throw any errors, but otherwise it will throw error when you are executing them. Once the parser verifies the syntax and the flow, then it goes to the optimizer part. The optimizer or optimization code, optimization is done for the code. This is basically like deciding which command to run first, which command to run next, right? So we are basically optimizing the entire code, right? This basically makes sure that the sequence is managed for your map and reduce tasks. Sequence is maintained or sequence is defined. Now, once this is done, then we go to the compiler. Now, this compiler is responsible to convert the entire code, right, into map and reduce jobs. Right? It will convert your entire code into map and reduce jobs. And those jobs are executed by the execution engine or executor. Right? Those map reduce are getting executed. Now MapReduce, it works on Hadoop and it works with the data which is there on HDFS or on, for that matter, local file system. It copies basically into memory and then does the transactions. Right? So this is basically how your flow happens. So parsers validates the code, then optimizes the code and compiles the entire code or script to sequence of MapReduce jobs. Parser check for errors, optimize the code, right? Then generate sequence of MapReduce jobs and then execute those jobs. Very simple architecture. This is your Apache Pig architecture. Now, Apache Pig can be executed in local mode or MapReduce mode. This is default mode. Now, as I said, Apache, animal, right? The pig can be domesticated or can live in wild, right? So the same way, Apache Pig can be executed on the data which is in local file system, or it can be used to execute the files which are there on HDFS. Excuse me. So the data can be on local or data can be on HDFS. Only data, mind you, right? So Apache Pig is using JVM for executing the code. Okay. Now, if you're working on, let's say, testing purpose, or if you're dealing with some kind of POC on a sample data, then we prefer local file system. I don't need distributed computing environment for computing the data. So your data is a single file which is located on a local file system. So simply you take the data and execute it. Well, executing, mind you, it uses MapReduce capabilities, right? But storage, HDFS, local. Now, if you're working on production level file systems or production level data, or you have large data on which you want to execute tasks, then you use HDFS as the storage. That means your data is split into different files, right? The data is stored in different blocks in different nodes, right? It's a very big file, big data. Then you use HDFS as a storage component. MapReduce will remain MapReduce. Okay, right. Pig, if I have to start in local mode, then I have to use this. By default, Pig will start in MapReduce. Hence, even if you just do Pig, it will start Pig on MapReduce mode. Or you can also type this way, right? We can try any one, that's okay. But make sure your data is there on HDFS if you want to try this. So any file that you're creating, maybe make sure that you're storing that in HDFS if you want to start Apache Pig practice there. Execution wise, there is no difference. Remember, only the file storage will vary if you say local or MapReduce. That's the only difference. Next, the execution can happen in different modes. Right? Execution modes. The data storage modes are different here. Your execution modes are different. So when you're executing the command, right? The commands can be executed in interactive mode. When you say interactive mode, line by line, we execute the commands. Right? When you write up a command, you type one line, then you execute it. So when you execute it, it is getting parsed. There's nothing much to be optimized. And then compiled. So your compiler is going to change that code to MapReduce and then finally executing. Single line. Then once that line is done, we take another line. So line by line execution can happen. Like you have seen Python scripts, right? Python also is an interactive mode. R also is an interactive application where line by line command can be executed, right? Then it can also be executed in scripting mode. Scripting mode basically means you have a .pig file. This is a script. You can simply execute the entire code, right? Just like how I have .r file or .py file, same way you'll have .pig file, which is nothing but your pig commands, pig script. And we can execute that in the single go. Or we can also put this Apache pig in between some other code. So you are working on some Java code. Okay. Between Java, I mean, when you're executing that, you might also want to call pig commands, pig script, right? So that way also you can embed pig class in Java code. So you can do interactive execution. You can do scripting mode and then embedded mode. Anything is possible, right? Next. Okay, this is something that we need to deep dive and understand. Let's not go there. We'll talk about that tomorrow. And then we will see the hands-on. Right? These are the commands. And if I have to quickly compare it with SQL, we already know SQL, right? So there's a bunch of similarities that we have, right? I'll not talk about all the similarities today because there is something that we need to learn before I can explain these things. But yeah, SQL is a declarative language. You say, you declare, you need this. In SQL, you're giving command to your database saying, hey, I want this. You're declaring things. Apache Pig is procedural language. You're basically trying to follow a process or procedure saying, okay, let me do this, let me do this, let me do this, and then I'll get this. Right? So that's difference between Pig and SQL. Now for SQL, remember it is the interactive language or standards to deal with RDBMS databases, right? And data in RDBMS will always be structured. When I say structured, schema is mandatory. Schema is mandatory. Whereas in Pig, it can work with structured data, semi-structured data, and unstructured data. So that means schema is optional. Here there is no schema in fact. Right? So we are saying schema is optional. Without schema also you can deal with data. Right? Now in Apache Pig engine, we talked about parser and then we talked about optimizer. That means whatever the code that you're writing is getting optimized internally. You don't have to explicitly do optimization of the code. Code optimization means you'll have to write the best code basically to get the task done. Minimum set of lines should give you, right, the results. Yeah. So that's basically called as your optimization. Right. Now, if I have to do that optimization in SQL, then you are manually trying that. Optimization is manual. Right? And we generally say code optimization. Right? SQL developers who are experienced developers, they generally do optimization of the code. This helps in performance tuning. This helps in performance tuning. Right? So internally, there is nothing happening. So you have a lot of flexibility to do it. Right? As a developer, You can do that, right? Whereas here for developers, there is no scope at all because internally it is optimizing. For subject matter experts, Pig is very good because it takes care of optimization, right? Whereas for experts, SQL is better because it gives them the flexibility to write the best code, right? Then we also have lazy, non-lazy transactions. What does those things? We'll try and understand. But yeah, probably we'll wait for the concepts that we discussed today to sink in. Okay. And then tomorrow we will do installation. It's very, very easy installation. It's like downloading and start working. Okay. Now to download the software, I'll show you. I'll just show you the link. You'll have to be ready with the software. All you're doing is going to search for Apache Pig download, right? So go here, go for your Google. Yeah, go for Google search and then say Apache Pig and then say download. It gives you pig.apache website. This is the home directory for Apache Pig, right? And here you see releases. There is something called as releases here. Okay, in this section, the second option is releases. Click on that releases. Yeah, this is your releases. Under releases, you have download. Right? You can click there or you can also scroll down here. It's nothing but your download location. Right? Same thing. Click on download a release now here. Releases may be downloaded from Apache Mirrors. So when you click on that, it is redirecting you to the releases. Here you have Pig location or mirror site, cloud-based mirror site. Click on this. Downloads.apache.org/pig. When you click on this, it would give you the location where you can download the software. The latest one is nothing but 07. You can also directly go to this folder. Now, in this folder, what is that file you want to download? Or what is the file that you have to download? Take the file which has maximum size, 220 MB. This is the file that you have to download. You click on this. It will ask you to save file, save it. And by default, it gets into downloads folder. Make sure you download it and keep ready. Yeah, everyone followed? Just go to Apache Pig folder and explore. You'll get the download link. And download it. It is 220 MB. Make sure you're ready with that software. Right, that's it for today. We'll try and do Apache Pig tomorrow. And then we'll have Apache Hive. Right, then we'll move on to HBase theory, Scoop, and then Spark. We'll spend more time in Spark. Yeah, Ashner, please go ahead.
Sir, did you encounter some problem like when you copied from local file using that dash foot going to the Hadoop file? My data node is keeps on dying.
Data node skips.
Yeah, keeps on dying. So I started it. The data node is there, and then when I try to do the copy, then it will encounter some error. I can copy the error. This is the error that I encountered.
What is that error? Did you explore that in the log files? You generally have to check the log files to see what is the error, why it is dying. Did you try to explore that? Yeah, Ashna? Okay. No, this is the log file error, or it's a warning message that I'm saying. It's not an error. Data node is dying. Why it is dying is something that you have to check, and that information will be there in the data node logs. So if you go to Hadoop location, if I come here in Hadoop home, I have a folder called logs. Under logs, you will see data node log .log file, not out file, .log file for data node. Open this, and then you will have to check why data node is failing. When you say JPS, do you see all the services up and running? Ashner, I'm not able to hear you. You're on mute.
Sir, for example, in the start, there is, when I try JPS, it will show me all the data node, the name node, the secondary name node, and then for the yarn also. After that one, I try to copy from local going to the Hadoop itself. Then after that, the data node will be dead. So I try to JPS again. The data node is now missing.
So it is not about copying, Ashner. Even before you copy, the node is getting failed. Data node is not able to start properly. Go to the log file, this log file, and check why.
Okay, sir.
Yeah. There will be a reason you will be able to understand. If you're not able to understand, then yeah, you might want to ping me the error. I'll try to help you out with that error.
Thank you, sir.
Sure. Okay, guys. Thank you. Yes, Shruti. Apache Pig download. You will have this location. Apache.pig, right? Apache.org.pig. You can see this is the folder. pig.apache.org. Yeah, and then go to download section and download the large file. Yeah. All right, guys. Good night. We'll connect tomorrow.